equations, a few examples of them. So let's try to tackle here then the absolute value inequalities. Well, let's look at one or two of those in particular. Absolute value of x is greater than 5. Well, we're looking for, again, the absolute values where we have greater than 5. Well, let's think about a number line scenario there. And looking at different values, if I start here at 0, well, obviously 0, we're not going to have that be a true statement. 0 is not greater than 5, or absolute value of 0 is not greater than 5. Nor would 1 work, or 2, or 3. Actually, let's think about 5 here. Go all the way up to 5, and then look at numbers after 5, like 6. If I plug in x to be 6, absolute value of 6, well, that is certainly greater than 5. So 6 is going to work, 7 is going to work, 8 is going to work. Matter of fact, all these out here, including like 5.5, plug in 5.5, that'll work. Everything right up until 5, and then beyond 5, actually satisfies this inequality. Now 5 itself doesn't, so I'm going to parentheses that off there. So everything after 5, might say 5 to infinity there, is a solution. Now, that's not the only ones though. We got to look back here. If you look at the same scenario, but look at numbers after -5. Or before -5, maybe you should say. Before -5, we've got like a -6. -6 does work because you plug in the absolute value of -6. Check it out here. That's true, isn't it? Because the absolute value of -6 is +6, and that is greater than 5. So -6 works. How about -7? Well, you plug in -7, it's also greater than 5. Now in here, -4, is that greater than absolute value greater than 5? No. So it's only these numbers after -5 there. So it's everything to this side of -5, including right up to -5, but not -5. So I'm going to parentheses that. So here's what I've got, and that's that would be -infinity, -5, and since I've got two parts, they usually separate that with what's called a union sign. So this is these are the solutions. Now, if I write that as two separate inequalities here, notice this side would be x is less than -5. On the other side, well, it's everything greater than 5, so that would be x is greater than the 5. Well, I mentioned that because that's the key here to solving these inequalities, because I mean we don't want to go through that whole process each and every time. So let's think about here what I did. Kind of like before with the equations, what I do is I set up two separate inequalities, and notice the second one over here. Well, it's really just kind of like removing the absolute values. Looking back at the original one, we just kind of dropped off the inequality. The second one, though, you might notice there, what I did was I changed it, or the first one, this one over here on the left, I changed it to a less than, and I changed it to a -5, and that's going to be the key to solving these inequalities, or setting it up like this. Let's take that and look at second example here. Let's say we've got the 2x plus 3 greater than 7. Well, if we follow the pattern that we learned earlier there, I'm going to do the 2x plus 3. I'm going to do two inequalities. And this second one, let's do it. The second one is just kind of dropping off the inequality, the absolute value there, and just make it a 2x plus 3 greater than 7. Now the first one, remember what we did there? Well, we changed it to a less than, and we changed this to a negative 7. If we solve those two inequalities, that's going to be our solution set for this particular inequality. All right, so now what would that mean? Well, we subtract 3, and we got 2x is less than negative 10 divided by 2. So we've got x is less than a negative 5. On this one over here on the right, subtract 3. 2x is greater than 4. Divide by 2, and we've got x is greater than 2. So our solution set then are those two inequalities there. X is less than negative 5, so if I draw that on the number line here, less than negative 5, yeah, that would be this, wouldn't it? This part of the number line is less than negative 5. X is greater than 2, well, that would be everything greater than 2, not including 2, so I use parentheses. So that's our number line, and then that's interval notation. Well, that's pointing to the left here, and so that's the negative infinity way, comma negative 5, parentheses around those, and then 2, comma infinity is the other interval there. And like I said before, usually if you have two like that, you put a union between them. Okay. Now, you might note there that that's a greater than absolute value equation. A little something different happens with the less than absolute value. Let's play the same little game here with a real simple one. X is less than negative 3. The absolute value of x is less than 3. In that particular case, if I look at numbers that work, well, let's just try some out here. 0, 1, 2, 3, 4, negative 1, 2, negative 3, negative 4. Take those off. What you'll notice there is, what about 0? 0, plug that in, absolute value of 0 less than 3. Yeah, that's true. What about 1? Absolute value of 1 less than 3. Yeah, that's true. 2. Yeah, that's true. Absolute value of 3 less than 3. Nope. Absolute value of 4 less than 3. Nope. So it's working all the way up until we get to 3 there. But it doesn't work after 3, and 3 doesn't work, so we're just going to parentheses that off. Well, if you notice back here, negative 1, the absolute value of negative 1, well, that's true too, because you're doing the absolute value of negative 1 is positive 1. Absolute value of 2, that works. Absolute value of 3, though, of negative 3, excuse me, is that less than 3? No, because that would be 3 is less than 3, and that's not true. And even going back a little bit further, negative 4, the absolute value of negative 4, is that less than 3? No, because we're doing the absolute value. Absolute value of negative 4 is positive 4, and that is not less than. So again, we have the same scenario here. It's working until we get to negative 3, and then at negative 3 it kind of quits working. So look at what we have. We have from negative 3 to positive 3, if we write that in interval notation, we've got that. All right, well, if we think about that in an inequality scenario, here's what we've got. Remember that this kind of going a different way than normal, but remember this interval notation comes from an inequality like this, where we have x between negative 3 and 3. Negative 3 is less than x is less than 3. That's the inequality that would mean. All right, so what can we say about that? Well, if we look at going from here then to here, negative, we've got the absolute value of x is less than 3. Well, that's different than or greater than in absolute value inequality, because to solve an absolute value inequality that's less than, what you've got to do is set up a 3-part inequality. And look at it, it has the expression x is between the negative 3 and then positive 3. So let's see if we can apply that to number 4 here. The absolute value of 4x minus 5, that's going to be less than 7. All right, well, with a less than absolute value inequality, what we're going to do is we're going to set up a 3-part inequality, and that 3-part inequality is going to look like this. We're going to put the 4x minus 5 in the middle, and then we're going to put the negative 7 on the left and the positive 7 on the right. And then the inequality, less than inequality is there. Well, we solved these earlier in the previous section there. Yeah, just a 3-part inequality. Now, to solve the 3-part inequality, you just get the x in the middle, isolated by itself. So I need to get rid of the minus 5, I need to get rid of the 4. Let's do that. All right, so to get rid of the minus 5, we add 5. But remember, it's a 3-part. You got to do that to all 3 parts. Negative 7 plus 5 is negative 2. And that's going to be then in the middle, less than 4x, because the minus 5 plus 5 is 0. And that's going to be less than 12. Well, you get rid of the 4 now. Get the x by itself in the middle, so we got to divide by 4. Because that'll cancel those 4's out. And yeah, look at this. I've got negative a half is less than x. Reduce those by 2. And then reduce that down to 3. Hey, how about that? Now we've got our solutions. We've got x between negative a half and 3. So on the number line, where that's what we're talking about. Part of the number line between negative a half and 3. And then interval notation of that would be negative 1/2, comma 3. All right. So we have 2 scenarios for absolute value inequalities. And I wrote down a couple of guidelines for you here. If we have an absolute value inequality that's greater than, what you do is you set up 2 equations. You do the expression in the absolute values. Ax plus b is just my general form of that. So you set the expression in the absolute values less than negative k, but then you also do the expression in the absolute values greater than k. You do 2 inequalities for an absolute value greater than inequality. For an absolute value less than inequality, well, you do 1 inequality, but you do a 3-part. You do the expression, and then you do negative k on the left, and then just k on the right. All right? So let's try that out on 2 more problems here. Okay, so we have to think here. We got 2 minus 3x is greater than or equal to 13. Well, that's a greater than inequality, absolute value inequality. What do? Well, what we do on absolute value greater than equality is we set up 2 equations. We do the 2 minus 3x in 2 separate inequalities. We do a less than, and in this case we got the equal to, so we do a less than or equal to negative 13, and we do the 2 minus 3x greater than or equal to 13. You see what happens. Those 2 will give you the the two parts of your solution set. All right, well, let's notice what happens here. We subtract 2, that'll give us, on the left, negative 3x is less than or equal to negative 15. And then, well, here's what happens. Divide by negative 3. Well, might star that because what happens when we divide by negative 3, a negative number in an inequality? Well, that reverses the direction of the symbol. So we're going to have greater than or equal to now. So we have x greater than or equal to 5. Okay, so that's one part. Now over here something similar happens. We subtract 2. So we have negative 3x is greater than or equal to 11. Divide by negative 3. And we've got x, but we divide again by a negative, so that changes it to less than or equal to. And 11 divided by negative 3, well, all we can really say there is that's negative 11/3. Positive divided by negative. All right, so see what happened here. We've got x is greater than or equal to 5, so on the number line, we're talking everything greater than or equal to 5. So here's 5. Everything greater than or equal to be this side, right? Equal to means we include the 5, so bracket that off. On the other one, x is less than or equal to negative 11/3. Well, that'd be over here. Let's just call it there. And then less than or equal to, well, that would be on the less than side, would be over here. We got the equal to part, yeah, so we bracket that off. And so we have interval notation, we have negative infinity, it's negative 11/3, since this one points back this way. Parentheses that, but bracket that. And then on this side we have 5, comma, infinity, since it points that way. And we want to include the 5, so we bracket it, and infinity always gets a parenthesis, so it'd be parentheses there. And then we have 2, so we union that up. All right? Last but not least, the absolute value of 4 minus x is less than or equal to 1. All right, so we've got a less than absolute value inequality. What do we do there? Well, we think back to our guidelines here. A less than inequality, well, that's this scenario here, isn't it? I got the absolute value less than. So what do? Well, we set up the 3-part. That's when we go to the 3-parter. So I'm going to do the 4 minus x between the negative 1, and notice I put the less than or equal to because I got the equal to part there, and then less than or equal to positive 1. So we do the expression, and then we do minus 1 on the left, positive 1 on the right, 3-part inequality. We solve that out. Okay, well, here's what happens. We to get the x by itself, let's subtract 4 from all 3 parts. So we have negative 5 is less than or equal to, and then in the middle we just have a minus x, since the 4 minus 4 is 0, and then less than or equal to a negative 3. All right. Well, we still need x by itself, so we're going to divide by negative 1. And we are dividing by a negative again, and so that's going to kick in and make that a greater than or equal to, and that greater than or equal to. We've got to reverse the direction of the symbol. So let's see what happens. Negative 5 divided by negative 1, that's positive 5. Negative x divided by negative 1 is positive x. Greater than or equal to negative 3 divided by negative 1 is positive 3. What happened was, well, everything switched around, but as we've seen earlier, that's okay because 3 is here, 5 is here, 5 is greater than. That means, again, just everything between the 3 and the 5. We do have the equal to 5, so that brackets that. The equal to 3, so that brackets that. So the interval notation is 3, 5. One other quick little word here. Might note here not to get too carried away, because this is only what we need to do for an absolute value equation. If I'm just doing 5x plus 3, that's greater than 13. That's not an absolute value equation. In that case, all I have to do is solve that out. Subtract 3, 5x greater than 10, divided by 5, x is greater than 2. I only have to do this special two-part inequality or a three-part inequality if I have an absolute value to start with. If I just have a regular inequality, linear inequality, you just solve it. But absolute value, that's when you use those guidelines that we talked about earlier.